All right, welcome back, guys. In today's class, we're going to be discussing the OSI model. The OSI model, all right, basically stands for the Open System Interconnection. All right, so we're going to be looking at the layers, all right, that we have in this model. There are 7 layers in the OSI model. Okay, so we're going to be looking at each of the layers, all right, and the importance, all right, of the OSI model to communication between our systems, basically communication between our computer systems. Okay, so let's take a look at the OSI model. Now, the OSI model is actually a framework created by the International Organization for Standardization. And the purpose for this framework actually is that in the early days, when we started having computer systems, they realized that, computers from different manufacturers were not able to communicate with one another. Okay, so if you have a system from HP, for example, and then you have another system from Dell, for example, right? It means that if you connect the two systems together, these systems are not able to share resources. They are not able to communicate. All right. Now, it's not as if there was anything wrong with the system. It's just that, the systems are built on different standards or protocols. Okay. So they are not able to share, all right, resources. Now, the IOS, which is the International Organization for Standardization, now came up with the OSI framework, all right, which every organization that manufactures computer now have to follow. And that basically is what helped to solve that problem. So even within an organization, if you have computers from different manufacturers, all right, as long as the manufacturers have designed and built the system based on the OSI framework, then there shouldn't be any issues amongst the systems in terms, all right, of network communication. Okay, so that is basically the problem that the OSI model, all right, solved. So now in your office, in your home, anywhere that you find yourself, all right, regardless of the system they are using, regardless of the system that you have, if you connect to their network, you are able to share, all right, resources on that network. All right, because every computer manufacturer, all right, has built their system, all right, on these standards. All right, so there is no longer discrepancy as to, I can share just with my, with computers that come from a manufacturer. All right, that has been eliminated. Okay, thanks to the OSI model. Now, the second thing that the OSI model, all right, has, helps us with also is the fact that it is still very useful when it comes to troubleshooting network problems, right? Yeah, remember in the first slide that we saw that we had 7 layers of the model. Okay. Now, when you're having network issues, okay, this model can still guide you as to, what you should look out for, all right? Where should you start your troubleshooting from? All right. So following the OSI model, it is easier to troubleshoot network problems. Okay. So that is one of the things that the OSI model also solves. Now, the OSI model may not be, all right, the prevalent framework that we use in modern systems of today, all right, but is still very, very useful. Now, the one that we use today is called the TCP/IP model, and basically the difference between the OSI model and the TCP/IP model is that, in the TCP/IP model, all right, certain layers were collapsed into one, right? For example, in the OSI model, we had, the application, the presentation, and the session layer. But in the TCP/IP model, all right, the application, presentation, and session layer were actually collapsed just into an application layer. All right. So in the OSI model, you had 7 layers. In the TCP/IP model, you have, all right, just about 4 layers, right? Application, transport, network, and the physical layer, right? So you have just 4 layers. Okay. Now, let's take it a step further. So let's take a look at the 7 layers of the OSI, all right, model. Now, starting with the first layer. Now, the first layer is referred to as the physical layer. All right, is referred to as the physical layer. Now, The physical layer is where the connection happens, right? Now, if you are connecting and you're watching this video, whether you're watching on your mobile, whether you're watching on your laptop or your tablet, all right, now you didn't just pick up your computer or your device, for example, and then you just went to YouTube like that, right? The first thing you had to do was to turn on the data on your mobile phone, for example, right? Now, if you're in a place where you have access to Wi-Fi, what do? You turn on your Wi-Fi and you connect to the internet. Now, without that connection, okay, you wouldn't be able to stream the video as you're doing right now. All right, you won't be able to download anything on the internet. So the first thing you do if you have any business on the internet is to what? Is to connect, all right, to a medium that gives you access to the internet. So now if you're in an office, you can connect through a cable. All right. And if your office also uses a Wi-Fi, you can connect through a Wi-Fi. Now, if you have a mobile phone and then you have, data subscription, you can also turn on your data on your mobile phone, and that gives you access to the internet. But one thing that is certain is that before you can access the internet, there has to be a mode of connection. All right. Now, that can either be a wireless connection, it can be a wired connection, right? So that has to happen. So that's the first thing you have to do. Now, at the physical layer, all right, you are also sending data, all right, to the receiver in ones and zero. Remember, what your computer understands is what is zeros and ones. Okay, so all of that transaction happens at the physical, all right, layer. And there are a few things, all right, a few devices, all right, that, are basically at that layer. Okay, for example, your cables and your connectors, okay, they are basically functioning or they function at the, all right, the physical layer. Your hubs and your repeaters, all right, these are old, switch technologies and all that, they function at this layer. Okay, now let's take a look at the second layer. Now, the second layer is what is referred to as the data link layer. All right, the data link layer. Now, at the data link layer, all right, you transmit data in the form of frames. All right, data are transmitted in the form of frames. Now, at the data link layer is where you also have your, your modern switch, all right, or switches of today, right? Now, when you have two computer systems connected to the same switch, all right, now they can exchange data, all right, by sending what you call frames, all right, and then this sending of data, even if the two systems do not have an IP address, remember, every system has a unique ID called the MAC address, all right, the media access control address. Now, the MAC address is an hexadecimal address, which means it's a mix of numbers and letters, all right, but it is unique, all right, from one system to the other. So at the data link layer, the two systems that are connected to your switch, all right, they can send frames to one another using, all right, their MAC, all right, address. Okay. Now, at that layer also you have a few things. For example, you have your switch, and then of course you have your network. All right. So let's move on. Now we have the third layer. Now the third layer is the network layer. Now at this layer is where you have your internet protocol. All right, your IP addressing. Okay, now if you've not watched the video on IP addressing that we did, all right, before this one, it is linked in this video. All right, try as much as possible to get your hands on it to understand, all right, what IP addressing is about. So at the network layer, which is the third layer of the OSI model, is where you have, all right, the IP addressing. Now, at that layer, you are not transmitting frames, you are transmitting what is referred to as what? As packets. All right, that is what you're transmitting. Okay, so at this layer, there are a number of protocols that also, all right, are tied basically to this layer. All right, so for example, you have your router. Now, your router is what is responsible for all right, communication. Okay, intercommunication. Now, at the layer 2, where you are sending frames, All right. Now that layer is responsible for intra communication. All right. Your layer 2 is what? Is responsible for intra communication, which means communication that is happening between two devices that are on the same network. So that happens at the layer 2, all right, of the OSI model. But at the layer 3 of the OSI model, you can have what you call intercommunication, which means, all right, one system on one network can communicate with another system on an entirely different network. All right. And the device that facilitates that is what is referred to as what? As the router. So the router facilitates, all right, that intercommunication. Okay. And then you can send packet from your system to another system that is not on your network. Okay. Now, for some reason, also, the router can also be referred to as a gateway. All right. Basically facilitating this intercommunication. Is that okay? All right. So let's move on. Now, at the layer 4 of the OSI model, you have an important layer. All right. It's a very important layer, which is called the transport layer. Right. Now, remember, we have said at the layer 2, you're transmitting frames. At the layer 3, you're sending packets. All right. But then at the end of the day, something is responsible for moving, all right, whether your frames or your packet, all right, from point A to point B. All right, something has to be responsible for that. So which means if I send something, for example, if I'm sending an email to somebody, all right, now something has to be responsible for ensuring that that email leaves my computer or my mailbox, and then the recipient is able to get that email in their own mailbox as well. Now, drug transportation, right? Something is responsible for that. And what is responsible for that is the transport layer, all right? That is the layer responsible for that, all right, movement, okay, of data. Now, at this layer, there are two important protocols, all right, where, which basically all the services that we use today, all right, are built on this protocol or protocols. Okay. Now, the first one is what you call the transmission control protocol. That is the first one. Now, in the next slide, we're going to talk more about these protocols, but then just to give us an idea about what these protocols, all right, mean. So, transmission control protocol. Now, transmission control protocol is a reliable protocol, all right? It's a reliable protocol. Now, why is it called a reliable protocol? Okay. Basically, it ensures that if a sender sends something to a receiver, the transmission control protocol ensures that the receiver receives the whole message, all right, without any missing path. All right, without any missing path. Okay. Now, peradventure, if there is a missing path, all right, and then it gets to the receiver, all right, can request for a retransmission, all right, until all of the data has been sent completely, all right, without anything missing. Okay, but we're going to talk more about that in the next slide. So now the next protocol that you have in this layer is what is referred to as, all right, the user datagram protocol. All right, so you have the user datagram protocol. Now, the user datagram protocol is, well, you can say it is unreliable, right? And the reason is because it is used for real-time kind of operations like video streaming, voice over IP, and things like that. But we're going to delve more into them in the next slide. All right, moving on. At layer 5, you have the session layer. At the layer 5. Now, the session layer, from the name session, it is basically the layer that is responsible for establishing, all right, sessions between two systems. All right. So, for example, you want to do a Zoom call, for example. Okay. All right. So you create a meeting, you send a meeting link to the person that should join that meeting. All right. Now the person joins the meeting, and then once the person enters the room, the person is allowed, and then we start the meeting. Now, from the start of the meeting to the end of that meeting, something is responsible for ensuring, all right, that that meeting goes on smoothly without any kind of interference. All right. So that is the job of the session layer, right? The session layer establishes, all right, sessions between two, all right, parties. And then once the session has been ended, it also is responsible for terminating the session. So that is what the session layer, all right, does. Okay. Now, the sixth layer, all right, is what you call the presentation layer. All right. Now, the presentation layer, it does quite a number of things, right? Like encryption, compression, and translation. Okay, so when you go to any website and then you see the beautiful designs and everything that is well aligned on that website, all right, now what is responsible for that is what is the presentation layer, which means it is the layer that is responsible, all right, for ensuring that when users visit our website, they can, all right, relate with what we have on our website. Okay, all of the data on our website, all information that we have on our website is presented to them in an human readable format. Okay, so the presentation layer is what is responsible for that nice, beautiful looking, all right, presentation that we have on all the website. Okay, so if you go to Amazon.com, if you go to Yahoo.com, if you go to Facebook, if you go to Instagram, all right, all of those designs that you see where, all the boxes, everything is well aligned. Now, the presentation layer is what is responsible for presenting it to us in such a way that we can relate and appreciate, all right, what we are saying. All right. And if there's any form of encryption, maybe in-flight encryption and things like that, maybe the site using SSL and stuff like that, the presentation layer also handles that. All right. So that is what the presentation layer does. Now, the last layer in the OSI model is the application layer. All right. Now, the application layer is basically that layer that is, responsible, all right, for, quite a number of services that we use, all right, on the web. Now, this network layer, all right, hosts what you can refer to as the network aware applications, right? Like your web browser. Okay, when you want to go to any website, what do? You open a web browser and then you type in the address, all right, of that site. Now, and then you can access, this website on different services. So for example, at the application layer, you have a service like your HTTP, which is the most popular, all right, your HTTP service. All right, you have your email servicing like your SMTP. All right, these are services, all right, that are used, all right, at the application, all right, layer because they are network aware applications. Okay. All right. Now let's delve into the TCP, all right, and the UDP, okay, to understand, why is one reliable, why is one not reliable, and things like that. Because now the reason why we need to talk about the TCP and the UDP is because all of the services or other protocols, all right, that we use today, all right, day to day, we access a lot of website, we do a lot of things online, all right, all of those services are actually built, all right, on these two protocols, right? There is no site, there is no application that you're building that would not utilize either, all right, of these protocols. So it's either your application is TCP dependent or is UDP dependent, right? It has to be either of these two, all right, protocols. Okay, so that is one of the reasons why we need to look into, all right, the TCP and the UDP to understand them, all right, better. So let's take a look at that. All right. So I think I talked about the HTTP and the SMTP, all right, at the application layer earlier. So I forgot that I had an arrow there. So let's just go ahead and talk about the TCP and the UDP. All right. Now, the TCP, all right, employs a concept that is called the three-way handshake. All right. It employs a concept that is referred to as what? The three-way handshake. Now, remember, I said earlier that the TCP, all right, is a reliable protocol. Okay. Now, the reason it's reliable is because of this three-way handshake. Now, what is the three-way handshake? Now, let's take a look at this. Now, you have a sender that wants to send something. Okay. So, for example, the sender can be myself. All right. I'm trying to access, let's say I'm trying to access google.com. Right. Now, google.com is hosted, all right, somewhere, maybe in the US or wherever. Okay. Now, google.com is not physically, all right, that server is not physically in my location, which means in order for me to access that google.com server, I have to send, all right, something. Okay. And then I need to get a response back, all right, from that server. All right. So what the TCP does is that from the sender, it sends what you can refer to as what? A sync, a sequence number, or you can call it synchronization. Okay. But what it does is that it sends a sequence number to say, oh, hey, hello, I'm trying to access something on your website. All right. Can you give me the content? Is the content available? And things like that. Now, if that request gets to the server, and the server is ready to establish a connection in order to send the data that I have requested, right? The server is going to send me, all right, another response. Now, the server or the receiver will send me what you can call a sync, all right, which is to say, oh, I get your message and I am acknowledging, all right, that yes, what you are requesting for is available and we can establish a connection. All right. And then the sender will now send what? An acknowledgement back, all right, to the receiver or to the server. Now, that acknowledgement now means that a session has been established between the sender and the receiver. So now, once the three-way handshake has been completed, data transfer or transmission, all right, can now occur. Right? So that is why the TCP is referred to as what? A reliable, all right, protocol. Or in some case, you can also say it's a connection-oriented, all right, protocol, because it is a protocol that seeks to establish a relationship before any transmission takes place. Now, another important thing that we must also know about the TCP is that it also employs what you can call, all right, flow control and error control. Now, starting from error control basically means if I send two things to the receiver and then the receiver only gets to receive one of the two things that I've sent, all right, now on the receiver's end, all right, the receiver can request for a retransmission, which means the TCP is not just going to send something and then not follow up. All right. So the TCP, once it has sent anything, it follows up to ensure that what I have sent gets to the receiver intact, nothing missing. Now, an example of that is when you send an email to someone. Now, if the email address is not correct, all right, you get a response back in your mailbox, right? You get a response back telling you, oh, the address is not correct. So that's a feedback mechanism. Now, that is what is built into TCP, which means peradventure the email was not delivered, then there should be a response back to know that, oh, what we have sent didn't get to the recipient or the email address is not correct. Right? So the TCP protocol is not a protocol that looks away, that just as well I've sent it, whether I get there or not, it's none of my business. I have done my part. No, it does what? A follow-up. And that is why the first thing that happens is to send a sequence number. The recipient also responds by acknowledging that sequence number. The sender also sends an acknowledgement, and then a relationship is established. Right? So the TCP ensures that if I send you one thing, then you must receive the one thing as a whole, right? Even if there's anything that is broken or something has not gotten to you, you should eventually get all the data intact. All right. So that is the TCP, all right, for us. So don't forget to just quickly recap. The TCP is reliable, it is connection oriented, and it employs, all right, a three-way, all right, handshake to ensure, all right, that reliability. Is that okay? All right, so let's take a look at the UDP. Now, for the UDP, of course, you have the sender, you also have the receiver. right? But then the UDP is connectionless, which means it does not care. I have sent it, right? It just sends everything. So the UDP does not seek to establish a relationship. All right. It doesn't seek to say, oh, well, I'm trying to send you something. Are you available to get it? So whether the server is available or not, the UDP just sends. All right. And that is why it is basically used for real time, all right, kind of connection, which means if at any point in time something fails, right, it doesn't bother about retransmitting. Okay. It doesn't bother about that. Okay. So that is why the UDP is what? It's connectionless. It is not about relationship. It's not trying to establish any synchronization or sequence or anything. It just sends data. Now, a very good example of that is, when you are on a phone call with someone, right? And you're making a call. Now, in the middle of that call, if something happens to your connection and you're saying hello, all right, or you're trying to just say something. Now, if something happens and the person on the other end cannot hear you. Now, with UDP, everything that you have said is not going to be retransmitted to that person, right? Everything that you have said is basically gone. So what do? You cut the call and then you call back again and then you try to pick up from where you stopped, right? But all of those things that you said that the person didn't get to hear, that means you'll have to repeat them all over again. So with UDP, it doesn't care, about retransmission. There's no error control and things like that, right? So if you don't receive it, that's the end. Okay, I'm not bothered. So that is why UDP is referred to as what? As a connectionless, all right, protocol. Is that okay? All right. So now let's look at port numbers. All right. Now, for every of this protocol, for every of the services that are built on this protocol, they each have what you call a port number. Now, the port number is like an address for a service. All right. For example, the popular HTTP has a port number 80. So the port number 80 is more like an address for HTTP. So anytime you say, oh, my application is connecting on port 80, what you're saying is that my application is what? It's an HTTP application. All right. Now, there are three, all right, categories of port numbers that we must understand. Three categories. So let's take a look at them one by one. So we have what you call the well-known ports. Now, the well-known ports, all right, are ports that range from 0 to 1023. Now, these well-known ports are ports, all right, that are basically, all right, registered and standardized by the IANA. Now, if you've not heard about the IANA, I encourage you to watch the video, all right, on IP addressing that we released, all right, just before this one. Okay. Now, the INA is basically Internet Assigned, all right, Numbers Authority. So they are in charge of allocating IP addressing, standardizing port numbers and things like that. So the well-known ports are ports that have been standardized and, of course, are duly registered, all right, with the INA. So which means these are port numbers that you cannot modify. For example, HTTP is on port 80, right? So you can't modify that. All right, there's nothing you can do about that. HTTPS uses port 443, for example, which is a secured version, all right, of HTTP. So if you want your application to connect on HTTP, you can't say, oh, well, I want on HTTPS rather. You can't say, well, I want to use port 444. That's not possible because the standard port and the recognized port, all right, for HTTPS is 443. So is either use 443 or you just, won't be able to connect your application using SSL, right? So that is well-known port. Now, the second one is what you call registered ports, all right? Now, registered ports are also ports that are assigned by the IANA for specific service, all right, upon application by a requesting entity. Now, there are other applications that are also using registered ports. An example of that is your MySQL database. Now, MySQL database uses the port 3306. Now, that is far above the 1023 well-known port. All right, but it's a registered port, duly registered, all right, and standardized by the IANA. Okay, another registered port that is also popular is the RDP, right? Remote Desktop Protocol, which uses 3389, for example. All right, so that's also a registered port. So a registered port basically is something that has to be requested. You have to you have to apply to IANA to say, I am building a service and I want my service to be using, all right, or to use this particular port number, and then they go through application, and if all is fine, they approve it, and then they tie that port number to your application, and then it becomes, all right, your home. Now, the last, all right, category is what you refer to as the dynamic port. All right. Now, the dynamic port ranges from between 49,152 to 65,535. Now, just to let us know that, the number of the actual number, all right, of ports, that we have is actually 65,536. Okay. So these port numbers are now broken down into different categories, all right, well-known ports, registered ports, and dynamic ports. Now, dynamic port cannot be registered with the IANA, all right? It can be registered with them. Now, the purpose of this port is for temporary purposes and automatic allocation. Now, I'm going to show us, all right, a quick example using Wireshark, all right, and then we're going to see this dynamic port, all right, in action. All right, so it is basically for temporary purposes, and it can be automatically, all right, allocated. Okay, so that is the three, all right, types of ports that we have. Okay. Now let's look at, some services, right? What protocol do they use and what is their port numbers, right? So we just visit now. These services, for some reason, also, you can also refer to them as protocols, but I think they are services because, I mean, these are protocols or services that actually rely on either TCP or UDP. Okay, like I mentioned earlier, whether you are using, all right, HTTP, HTTPS, whatever, protocol you're using, it is still, all right, dependent on either TCP or UDP. So for me, I prefer to refer to them as what? As service. Okay. So we have quite a number of these services. For example, you have HTTP. Now the HTTP uses the protocol TCP, and the port number is port 80. You have your HTTPS, which is the secured version, all right, of HTTP, and the port number for that is 443, and it also uses the TCP protocol. We have the DNS, which is a domain name system. Now, in the next video, we're going to be talking, all right, about web servers, and we're going to be talking about DNS, right? It's also a very important topic you need to understand as a DevOps, all right, engineer. Now, there's the SSH, which is the secure shell. It's actually the protocol that we use to connect to our Linux server. All right, we're going to be using that a lot. Okay, so the port number for that is port 22. We have the SMTP, which is for our email that you send an email, you receive email. We have SMTP, and that also uses TCP, and the port number is 25. MySQL that I mentioned earlier, all right, uses TCP as well, and the port number is 3306. RDP also uses TCP, which is a remote desktop protocol. So if you want to log into a Windows machine remotely, all right, the protocol is RDP, and the port number is 3389. Now, what this port number means basically is that if you want to access any of this service, it basically means that if you have a firewall within your system or you have some security appliance within your organization, these port numbers must be allowed in order for you to access these services. Okay. So any of the services that you see here, all right, you can't just use them randomly. Okay. Your firewall, all right, must allow them. Okay. All right, in order for you to use all of these, all right, services. Okay. Now, quickly, if you go to Wikipedia, for example, you can also see on this website right here, you can also see a list of these ports. All right, so if you scroll down here, you can see the well-known port right here. And on the left side there, you can also see registered ports. So if you click on that, it shows you the registered port and then the numbers and of course the services, all right, that are registered on those ports. And then if you click here, you can also see, all right, the dynamic ports, all right, and then you can see them right here. So you can see that we don't have too many services on these dynamic ports. Of course, they are just ephemeral ports. They are for temporary use cases, all right? But quickly, let me just show you, all right, something right here. So there's this application here called Wireshark, all right, and I'm going to be using this application to just generate something, all right, on my own hand here. So I'm going to open up a new tab, all right, I'm going to open up a new tab, and I'm going to come here. I'm going to click on my Wi-Fi right here, all right, just to capture some traffic, just to show you, all right, the layers of the OSI model in action, all right, just to so that you can see them practically, all right. So I'm going to double click on this, my Wi-Fi, and I'm going to come here. I'm just going to go to Amazon.com, for example. All right, you can see that it's capturing some packets already. So just pay attention to that side. It's capturing some packets. So let me just, click on any item right here. So let me click on this one. So if I click on this item, for example, I'm just clicking on this to just generate data, right? To just generate data. Okay, so if I click on this item and I click on add to cart, for example, now that is, all right, all I have to do. So I'm just going to come here and then I'm going to say stop. Okay, just to stop that, traffic that I'm generating. So here, if I come here and I type in DNS, I just want to try and filter, all right, based on DNS, for example. So if I click on DNS and so if I click on DNS, it's going to give me some DNS queries here. So if you look at this, I have Amazon.com, all right, there's a query right here. All right, so let's just scroll down a bit and let's see if we can get some more information, right? So here, if I click on this, now look at what I have here. All right, so look at what I have here. Okay, so I have my domain name system. All right, now look at that. Okay, so basically there was a query, all right, to my DNS to basically look for Amazon.com. Now, but look at what I want to show you here. This is what user datagram protocol, right? So if you expand that, what do you have? Now, for the source port, it says what? It says 53. Okay, so I want to access 53, right? That's a DNS port. But then look at the destination port. You can see that it's using 64,000, all right, 979. Right? Now that is a dynamic port. It was generated automatically. Okay. So it wasn't that I assigned that port number to my system or anything. It was just generated dynamically. Okay, for that purpose. All right. So that is the dynamic port. Now, if you look at here, you have Internet Protocol version 4, and that shows us, all right, the destination address and it shows us the source address. All right, so that shows you where the packet is going and then the source. Now, these are just DNS, all right, stuff. This 0.1 is basically my gateway. All right, 0.1 is my gateway, 0.100 is my own IP address. All right, so that is basically, all right, OSI model in action. Now, one thing again I want to show us is this. Now, this is just DNS, right? So if you click on these, we're going to get, all right, some more information about what is happening, okay, about your data. Now, another thing that we can also filter is to filter using TCP. So let's check some TCP stuff. All right. So here I can see Amazon.com. I can see some, all right, acknowledgement. I can see some stuff from some sync right here. So if you click on any of these ones, right, it gives you some information also right here. So if you click on this, you can see that the source port is what? Is 443. The destination port is what? Is 554,000. All right, 489. That's also a dynamic port. All right. Now, the destination port is basically what was generated on my own system. Okay. That was generated on my system to send, all right, to Amazon. Okay. And then the source to Amazon is what is 443. Okay. Because it's an HTTPS connection. Right. So you can see all of those sync arc right here. So you can see the sequence number. All right. You can see the sequence number. You can see the acknowledgement number. All right, you can see all the sync arc analysis. If you expand this, you can see all the sync arc analysis and everything here. So you can see that the OSI model is not just an abstract idea, right? It's something that you can actually, all right, check out with, the system. So the destination address, this is my IP address, but the source address, which means the return traffic is coming from 13.224.223.9, and then it's coming back to my own, all right, address. Okay, so if you look at all that you have here, all right, this is basically, all right, your OSI model, all right, in practice. And then you can see the data link layer. So you can see the destination MAC address. All right, this is the MAC address, the destination MAC address, and all of that. And then you can see all the frames that was captured, right? We talked about frames at layer 2. All right, you can see all of that frames that was captured. So this is basically OSI model, all right, in practice. Okay, so with this little, all right, demonstration, I hope you've been able to understand, OSI model. You can download the Wireshark and just, do some practice on your own as well, all right, to just, gain some more, all right, insight into this thing. Okay, so thank you so much. All right, that'll be all for today. All right, so thank you so much, guys, for sticking to the end of today's video. We hope you were able to gain some insight, all right, into what we discussed in the video today. All right, we hope to see you in the next video, and we want to appeal to you once again. If you're yet to subscribe, please hit the subscribe button, like this video, share it to as many people that you know that will benefit from, all right, these sessions. Okay, so thank you so much, all right, and we hope to see you in the next video. Bye for now.